All right, welcome everyone to this, our second installation of the new Ronin Institute Public Seminar Series. Today we have Vesselin Gueorguiev, who is a member of the Ronin Institute, who has been a research scholar since 2017. His background is in computational physics and astrophysics. But currently, he is particularly interested in practical applications of quantum computing for business. And you may recognize him from his previous seminars, Quantum Computing History and Prospects from 2018, and Cosmological and Galactic Signatures of the Scale Invariant Vacuum Theory from 2019. But today, he is going to be talking about his latest hackathon adventures while staying at home during the pandemic.
Thank you very much for the introduction, and thank you all for finding time to come to my talk today. It's an unusual talk for me because usually I do scientific talks on my research. This is a talk that if I have to summarize it, probably I'll present it with one slide. And this is the summary slide of all the things that I've been doing the last few months and utilizing and using. But I'll go back to my traditional academic approach to deliver a talk, again, repeating the title of COVID-19 and cutting edge technology you can deploy from home yourself. The short title is Hacking for Fun During COVID-19. After all, we are all kind of confined to smaller than usual social and interaction spaces. And because of this, we would like to actually continue to have fun when we do our work from home. The outline of my talk, I'll have a short bio and background about me so that people would be aware where I'm coming from. And then I'll focus on application of the natural language processing to COVID-19, specifically the biosite and dinosaurs apps. And these are web pages where one can search literature on COVID-19 that are utilizing IBM tools. Another tool that we interfaced with IBM was Ask Watson chatbot, and it starts with G and W because this is actually a merger of Google custom search and the Watson assistant. And then, of course, the power of the IBM tools is that you can easily integrate with Slack or Facebook or other similar texting interfaces. And then the second half of my talk, I will go into what I'm really about, quantum computing and COVID-19. And of course, there will be some section about question and answers. Now, I encourage you to ask questions and either through the chat or the question and answer box. And since I cannot see the chat ones, then I hope that John would relay them to me as long as they are relevant to what I'm talking at the moment. And then other questions I can address at the end of the talk or in the right stage intermediately. So now briefly about my background. I'm originally from Bulgaria, and I came to United States to do my PhD in nuclear and computational physics. My master degree from Sofia University was in theoretical particle physics. My PhD was nuclear computational physics. Then I went to Spain to do more research in nuclear physics, specifically on the pairing problem. And pairing is very important for understanding superconductivity in condensed matter, but it's also very important in nuclei and understanding their spectral properties and reactions. Then from Spain, I came to United States at Livermore National Lab to continue my research in nuclear physics and to try to crash some of the supercomputers That was some of the top computers back then. So I did research there. And then I decided to stay in California, joining the UC Merced as a lecturer, teaching physics to engineers and science students. Then I spent about 10 years basically teaching engineers and pre-med students, astronomy also at Stanislaus State University. And my final teaching stunt was actually going to China, where I joined a new institute, the Sichuan Institute, Pittsburgh Institute in Sichuan University, starting their physics curriculum. And when I was in China, that's where I realized that quantum computing coming to an age, and that was a great opportunity for me to reconnect my theoretical physics passion for understanding quantum physics and go into practical applications, something that you can really utilize in some useful ways. So since then, I decided to come back and focus on quantum computing. But it's not just quantum computing, it's actually using quantum computing to augment artificial intelligence and machine learning algorithms. And this is kind of a summary of what I've been doing this year and a little bit from the end of last year. The first hackathon I started was actually a hackathon at Kaggle. And we produced question answer and question answering using Google Natural Questions Challenge. And this was submitted to Kaggle, and it was really great experience for me. And that's where some of the later teammates came from. The next one was the biosites. That was done with John. That was specifically focused on the COVID-19 problem that came up. And this was recognized as interesting direction at that time by the hackathon judges. And the reason it is like that, you hear a little bit more details in most of my talk. Then we start actually trying to figure out what is the really useful interface. And that's what I understand now, moving from academia into business, that this is really important, figuring out who are your customers and what kind of interface and features they would like. Because we were going with what we can do, what we think it is, but if you cannot find the right customer to guide you through building your interface for them, it's very difficult to make progress. And then the other chatbot that I mentioned, this is the Ask Watson. That was aiming at using interface, taking into account that most people nowadays, they don't use web pages on their computers, they use actually their smartphones. And a web page on a smartphone is not as convenient and useful as appropriate text messaging tool. So that's where we try to build this chatbot that could answer questions and also deliver more information. And then my quantum kicked in, and you can see here how my GitHub repo activities was ramping up over the months, eventually culminating in two activities. One is at the end of the CDL Quantum Hackathon, winning the Quantum Hackathon for the CDL Bootcamp, which was focused on advising which cities and what level of measures should be taken. We briefly named this which city should be closed and open, but actually we realized that you cannot really force a city to close and open unless their government decides and their officials. So all you can do is you can just advise, given the data, what would be the level that they will have to press on strictness. And this is using actually D-Wave to optimize the question, how do you keep GDP maximal because if you close cities, you're definitely reducing the GDP. People don't go to work, they don't produce enough, as usually they do. That means that your GDP is dropping. So this is optimizing GDP, but at the same time, you have to make sure that you're not overwhelming the health system by too many sick people in the hospitals. And this is the strength of the type of problems that D-Wave and quantum computers could be addressing these days. And here's another example, although this seems to be very simple in terms of trying to figure out how to go from one place to another if you have a list of cities you would like to visit. But later you will see I'll connect this to the latest hackathon that I did on GS1, which is related to the labels and understanding how different products are labeled and how data is distributed. So now I'll go back to one of the first projects, and this is the COVID score project, which I did with Don, Peter, and Srugina. And if you have a later access to the slides, or if you can type quickly enough, there's a link that you can watch this video, the promo video. But the problem we were trying to address is simple questions like how many people are infected in Hawaii. Should have a very simple direct answer, just giving you exactly how many people. Here's a snapshot when we implemented this in the chatbot, basically using the Johns Hopkins API interface. And this was the problem that we were trying to address. With Google, you get too many answers. This becomes actually as tedious to figure out which answers are reasonable and relevant to what you are trying to understand. And that's we were designed to work on a little bit more focused search engine. The idea was we'll have a user that would go through interface. In this case, this is the COVID scorer and doing a web page. And then depending on the behavior on the web page, they can have access to different data sets. We did our demo with COVID-19 bioarchive collection, where we used selected number of papers and segments for processing with natural language processing to answer questions through the interface, but also there could be a specialized web crawler that would build a frequent asked collection or any other specialized collection. And in case you cannot find a good answer in any of these collections, you can always use the Watson News collection that was built from IBM Watson as a demo of their way to collect news in English, French, Spanish, and German, few other languages. So that was the idea behind our project. And here I'll try to do something unusual. I'll try to play actually the submission to the dev post. That was the project where we got the winner highlighted project for the COVID-19 Global Hackathon. Hopefully it will open. And can you hear the sound? So actually this is not having much sound, so that I'll be guiding you what is coming on the screen. Here again, we are posing the problem that you get too many answers when you ask a simple question. But if you have the focused search engine, you get a little bit more focused, and you have entities like CDC. Everybody knows that this is important entity when you're talking about COVID-19. So besides keywords, you can search entities and concepts, and then you can actually refine your search by selecting these entities that you think is really relevant to what you're trying to understand in your research. So that was our first winner. Then coming back to my slides. As I mentioned, we tried to change the interface. We had another interface that we're building where, as I mentioned, the data sets are very clearly seen, like news, bioarchive, and frequently asked questions, collections, or crisis communications and remote notification resources. Is there a question? I hear something in the background. Or no, then I'll proceed. Again, here are the links from where you can visit these original projects. Now, after that, wondering what would be a better interface, we started the dinosaurs interface, where we now are hiding the collection. So that means that the user has to click here. And then we use a different way to express and organize the data sets. Of course, always we try to start with list of popular research search topics, and this could be changed as the search progresses, as well as through the activities. Now, here's an example in the dinosaur, how the collections look like. And this is actually a search engine, and I'll do a quick demo. This is incubation periods. Once this connects to the IBM interface, and hopefully it will go through quickly. Oh, I didn't select the collection, so let's see the news. No results. Let's see, is it working at all? Let's see this one. Maybe right now we are not really connecting. Yeah, I'm afraid that probably we are not connecting to the database and IBM. So hopefully later it will work a little bit better. But that's how the results would look like. And then clicking left and right, you see these passages where the focus is. And depending on the behavior of the user, then we will know whether this result was really relevant to what they were trying to find out by using our interface. Now, the next step is, if you're collecting enough data from the search results, then you'll be able to actually identify those questions that have very definite and clear answer. And these small answers could be redirected to the user interface, like texting apps on your iPhones. Although it may be coming from different collections, then knowing that this is a short answer, you can redirect it. If it's not coming from any of the collections, then you can always go to the Watson News and pull the answer from there. But the way that we implemented this was also utilizing this Ask Watson. And let me see if I can run this one. Do you hear the sound in the background?
No, you may be able to, under your share screen, you may be able to enable sound sharing. That may be an option that you need to select explicitly.
Yeah. I think I have to go in Zoom and do it right there. Stop sharing. and then start it again by selecting the magic options, and then it should work with a variety of hello, this is Ask Gladson team. We are building a chatbot with a variety of integrations based on IBM Watson Assistants. IBM Watson Assistant defines the chatbots in intents, and this is a chatbot that was used from IBM originally to address CDC COVID-19 questions. And variety of intents could be addressed in a different ways. The integrations one can try right on the fly while programming, or they can go and do the same thing through a web interface to test the chatbot and different answers and share with friends. Because down the road is Facebook to be used as integration capability. Of course, the questions and answers would be very much the same, just the interface for the chatbot is different. And these are intents about financial assistance that are addressed through IBM Discovery. Now, another integration is Slack, and that's integration that Peter would explain in a few words. Peter?
Thank you. Thank you. So, so if you don't have Facebook Messenger or any other any other messenger, you can certainly use Slack, or you can connect our chatbot into your organization's Slack account. You just have to install the chatbot as an app into your Slack account, and it will show up as a separate user, and you can ask it questions, and it will give you answers about the same content, and the experiences in Slack is the same as IBM or Facebook. And could you, Vesselin, would you be going to add a question?
His specific question about reopening businesses.
All right.
Now, this particular one was focused on intent, understanding reopening business phases and questions. And it's carried through Google custom search. And it was prepared by Don. Don, can you say a few words about the Google custom search?
Sure. So basically, custom search is a Google crawler that's customized to search only within certain links. So in our case, we added Yale Medicine and WHO as example links to crawl. And when you search for business reopening, then we scrape the data from those links and return the results to the chatbot.
And of course, they are the same results. Doesn't matter how we ask the questions and where. With this, we would like to summarize the advantage of the IBM Watson Assistant. Different data sets to be processed for different answers, from hardwired questions to news and specific frequently asked questions and other external Google custom search along with variety of integrations. Thank you for your attention. So, while I was playing this, I was also pasting some of the links in the Zoom group chat so that you can also attend and play with these chatbots. So as I said, this is the IBM Watson Assistant. And then unfortunately the link is very long that you can see there. But we try to incorporate, for example, Watson News to address questions about financial assistance. And then later when we added the additional notes within the assistant building on the original IBM starter COVID-19 demo app. Adding and programming actually a chatbot is quite different than usual type of programming. It's more like a flow chart, and this is an interesting way. I think almost everyone can do it as long as they're interested to create a chatbot like this. And the advantage what we found in the IBM was that you can really have a wide range of integrations. Third party like Facebook, Slack, and Intercom, I think. They were working on a voice telephony, also capable. And I think this is probably the future, because you would like to talk to your phone, it will translate, you confirm the translation of your question, and then you would receive your answer from them, and eventually it will be translated into voice back to you. Up here you can see the link to the chatbot that you can try. This is the web interface version. If anyone is interested, I mean, probably we can try to use the Slack, and you can integrate it in our Slack. I have my own Slack where I'm running a chatbot that is a moderator, monitoring what is mentioned in the chats, in the public chats, and what is posted. Especially when you post a picture, it will try to identify what is there on the picture. These are one of the cool things that one can play with these days in terms of chatbots. Now, as I mentioned, you can integrate this easily with Facebook. Now, during the pandemic, it was a little bit kind of a hurdle. We were stressing out that we cannot get actually public, because Facebook was restricting these web applications, and they was very kind of strict on what they would open out, because they didn't want to be flooded with misinformations and weird chatbots. Luckily, I didn't have to go to that stage. I could have done the demo on my site before I really go to the release to the public, and it's still closed for everyone. And here is the version that is running in actually in my Slack space that you also saw in the demo with Don and Peter. Now, we integrated the Google custom search with the purpose to address phase 2 reopening, like in California, and questions that are asking about reopening. So here we wanted to demonstrate that you can use different type of search engines, and you can actually use IBM as a hub through processing the different data sets and approaches, and then distributing it. This could be done also through Amazon and other platforms. For example, Microsoft is developing Azure as well. So this is kind of summarizing my AI and machine learning adventure at the beginning of the year and last year. And I want to point out that it would not have been possible if I had to run it on my laptop. So I'm really grateful to the Google Colab. There's an easy way and very in kind of free place where you can run your Jupyter notebooks and Python. You can do programming, and once it's done, you can send it to GitHub, and then eventually for other post-processing. And again, Kaggle is the place where you would go for huge data sets. As I mentioned, the Google Natural Question Challenge, which is about 4 GB of data. I will not have been able to process it here or using my Google account. But on Kaggle, because they are specifically focused on data sets, this is easily processable. And of course, we minimize the data later when we need it. Now, Facebook and Slack, of course, they have their agenda, but then they also give you a free ride up to some level where you can play. And so is the Google custom search. And this is the symbol for the IBM Watson. And there is a lot of tools in IBM Watson, like Watson Assistant and News. So any questions at this point about this previous discussion? If not, then I'll be jumping to the quantum computing. So here you can see a picture of the D-Wave. This is the front runner in quantum computing. But this is different from what you would expect as traditional type of computing where you're programming a code. Programming the qubits and gates, which is the standard way of programming computers, is known as gate programming for quantum computers. And IBM is the company that is at the moment the front runner in this space. They are very open, and again, one can go and subscribe to their Q experience and start learning about quantum computing and do some tutorials. Google is also one of the companies, and Microsoft, but as far as I know, the IBM is the most open. A local one here in California is Rigetti, which is a startup that is fastly growing. So this was accessed through the Creative Destruction Labs, and the next hackathon that I'll talk, the final one would be the GS1. That's how I finish my talk. But here I wanted to just point out the IBM Quantum Challenge that was in May. They were celebrating 4 years of quantum experience, and there were about 1,700 participants that were participating. I really enjoyed this challenge. And I almost solved the last exercise 4, but I'm going into numerical calculations rather than doing my analytical skills. I was tempted to do that and realize when I learn a lot about what even can be done nowadays after so many years of trying to do optimizations and what are the packages available to do that. In short, we don't have these optimizations working for 8 and more than 10 variables. It's really hard to be done. Another fun that I had was the community summer jam also in May. But I want to focus mostly on the CDL fund that I had. This was example how quickly the Creative Destruction Labs adjusted to the pandemic. They're, as far as I know, one of the few places for incubators and accelerators for quantum computing, open to general public, and any company could apply there and participate, and eventually if they have a great idea and great team, they may actually get support from them to build their company. What they did quickly, they realized that even though you cannot have a face-to-face interaction as usual, you can still build your teams through cohort weekly exercises. And here you can see 4 of the exercises for the month-long boot camp that we had. And this was really fun for me because I did a lot of physics that's related more to solid state and quantum chemistry rather than the usual physics that I've been doing. But then I found that a lot of this is well known to me in terms of mathematical framework. So there I mentioned that I was one of the top contributors in their cohort projects. And then the 2 specific ones that I like. This one grow into the final version that I will talk in a moment. And here you can see my GitHub and basically how from very rare use of the GitHub really was very active there. So the project that really won the hackathon prize for the bootcamp was the Q Alpha team, and these are the people that made it possible. As a result of winning the hackathon, we got about $6,000 in Canadian dollars, which we all split because everyone has their role in the process. This was a unique experience for me because I figured out, that it's really important to get your team on the same page. And I was kind of feeling very proud and convinced all these 4 people who wanted to do a project in the financial space and financial markets and financial industry to realize that actually doing COVID-19 forecasting as we did was the feasible thing to be done within 24 hours. So briefly about the project, that was some of the slides that Skylar prepared for presenting our project. What we were doing, we were selecting about 100 cities from the cities in United States that are contributing about 80% of the GDP in the United States. We are trying to maximize the GDP, but then we would like to stay within the limits, capacity limits of how many people could be in the hospital in the intensive unit being treated for COVID-19. So this is a constraint problem. And this is one of the examples that D-Wave can do. And if you try to do this in a regular computer, basically what you have to do, you have to go through 2 to the 50 combinations, and you have to evaluate these functions, and then you have to order these functions, and you have to see which one is the best solution. Of course, there is no one best solution. Most likely there are many solutions that are almost equally good within, for example, 90% GDP. And that's what we focused on. If you do a simulation of about 100 runs, then the cities that would come very often in particular category in these simulations could tell you, for example, what kind of suggestions you can have to these city governments, like extreme measures are needed for cities like Atlanta, Miami, Orlando, Phoenix, and Tampa. Remember, this was actually data from April and June. That's what we were looking for the simulations back then. And this is the number, how often this was shown that this city actually is having trouble and it's recommended from being a closed city to stay so closed city. And which city that were closed in March, for example, now can reopen because very rarely they show up in the simulation as a city with a lot of sick people impacting the GDP. So San Francisco and San Jose were some of the cities that were really doing quite well. And based on how often the simulation would point to the city, then we can actually quantify our recommendations. Now, similar optimizations could be done as a distance that you have to travel, given how many nodes you have to attend. And this is kind of familiar problem, similar and known as travel salesman problem. It depends whether you want to return back or you want to go from one city to through a list of cities, but you don't really want to know what is the original order. You just want to be looking for the optimal route. And again, this could be accessed through, let me see if it's available to quickly show it. This is here focusing on the fact that the city and also together across the state, you may not need to have a garage and final station where you put your cars. You just need to make sure that there is a customer from one point to the next point and people to maintain the cars when they need some maintenance. So with that, I am going to the last hackathon that I did with Tina. And actually the video that you saw, that was her creation. Of course, the whole team contributed suggestions. And these are the team members for the latest hackathon on vaccine distribution and route monitoring and using quantum computing, AI, and machine learning tools to address the problem of upcoming vaccine distribution. Basically, we have to identify now what means to have a high impact distribution. And of course, the first thing would be that we will want to protect the doctors. And that means that we have to evaluate high impact distribution of vaccine. When you vaccinate a team of doctors that can take care of many patients, this of course is high impact, but then of course, you have a finite number of vaccines to distribute. But once you identify what would be maximum impact distribution, you have to figure out the routes, and then you start executing the delivery, and you have to follow through delivery, because the delivery may actually affect the efficiency of the vaccine. And if this happens, you may have to rebalance your distribution to make sure that still you maintain a high impact given the circumstances. This actually could be applicable down the road to distribution of fresh fruits and other products, and products that could be restricted in their amount of how much is available to be distributed and their sensitivity or fragility. And of course, at the end, once one batch of vaccine, for example, is distributed, then you can evaluate all the assumptions and variables in your model, and you can try to improve for the next batch of distribution to make sure that really the impact is as you intended to. So here's the process. Basically, selecting the cities, zooming out to a region, for example, here around San Francisco, and then tracking with sensors the distribution of the vaccine and making sure that at each stage when you're delivering containers to a hospital, then the next stage when you move with your truck is actually the most efficient that you're taking to execute. So with this, I would stop and I'll take any questions. And I would like to also point some of the links. If anyone is interested, I can try to pull out. So any questions?
All right, so let me just thank everyone, thank particularly Vesselin for this excellent presentation, and let you know that we have our next public seminar is going to be on October 23rd. It's going to be Tom Buchholz talking about Messaging Matters, a checklist to enhance buy-in for your ideas. Most of our seminars also then become available on our YouTube channel. You can learn more about that there. You can also learn more about the Institute in general at roninstitute.org. I want to thank everybody for coming today, and especially welcome and thank you to people in the audience who are not, or at least not yet, members of the Ronin Institute community. And so with that, I will wrap up the formal thing. People have stuff to do and that sort of thing, should feel no guilt about taking off and leaving. But as I say, I believe that I very much suspect that Vesselin is happy to stick around, and if people have additional questions or want to play with the thing and talk about how these various cool tools that he's been developing work, I suspect he'd be happy to do that.